Hi, I'm Matt Look. I run the channel Look Creations, and as a few of you may have seen, I've been rebuilding this 1955 Elliott Shaper. It's a 14-inch stroke, and I've been at it about 9 months on and off. What the stage I'm at now is I've got to recondition the head and the sliding components of that head. The last couple of months I've spent a lot of time scraping in the ways on it all by hand. I now need to make myself a standard to allow me to print the dovetail surfaces, and that's an example of a small standard straight edge for printing flat surfaces. So for example, I've used it on some of these. I need to make one that will fit into a 55-degree dovetail, and we'll be making it from a scrap piece of cast iron from bin 13 at my favourite scrapyard. I'll bring you in closer and show you what we're doing. These are the two sliding or two components of the compound head which fits on the front of a shaper. Here's one we prepared earlier. So you've got a moving section and a fixed section, and the fixed section rotates around a pivot on the end of the ram, and the ram slides forwards and backwards. So for all intents and purposes, it's just like the top slide on a lathe, with the exception of, instead of having a fixed cutter, this has got a clapper box assembly. So the basic problem, as you can see on there, is it's had some pretty bad weather. It's been rusted over. It was stored outside for a period. I've not printed it yet, but I'm expecting this section here to be fairly badly worn, and that's the side the gib slit sits, and then on the other side you've got a dovetail, which I hope you can see. I'm expecting that to show signs of wear. Whoever owned this previously, I don't think they'd come across the concept of lubrication. They certainly run it like a gorilla. So I've got to basically scrape these contact surfaces into a bearing condition where they'll show a flat face with a 20 point per inch contact. And the way you do it is you have a flat surface which you put in a printing medium onto, in my case ink, and then you bring it up to this face, print it on, take it away and scrape away the high spots until you've got 20 spots left per inch. It's pretty straightforward when you're doing straight faces, flat faces. I've got a surface plate which is 24 by 18. Can't get into that with it. I got a straight edge which is a big cast iron thing. Can't get in with that. So I need to make basically a wedge which I can slide into there, tilt it up, print that face, bring it out, do the scraping, repeat on that face, and then repeat on that one. So given that Emma from Emma's Spare Room, Emma's Spare Room is a machine shop channel. She does some fantastic model engineering works, making small steam engines and the likes. She's running a competition for a set of Stan, I'm going to butcher his name now, Kaczynski or something, from Bar Z Industrial. He makes a fantastic set of 90-degree squares and 45-degree squares, all ground and honed and accurate to 2/10 of a thousandth of an inch, which I'd love to have. But as I need the tool to do the job, I figured, oh, I'll make a video. That's the last pass of 3. Took it in 20 mil depth of torque increments because I don't really know what's in it. It's cast iron, but it came off a bloody great big gearbox which I was hoping to get all of the cast off. Unfortunately, this was the only bit that I could get, 2 inches thick. Running at 60 RPM and feed rate is 0.36 mil per rev. It's not working it too hard, but I don't want to knacker the blade. So as I mentioned earlier, the piece of cast iron I'm working off was all I could find at the local scrapyard. I haven't got 40 quid for a piece of Durabar, so we're making do with what we've got. Only problem when you're using, one of the problems when you're using reclaimed scrap is you don't know how it's been handled, you don't know where it's come from. Given that this bit was just a sheared off plate, I was expecting to find some cracks in it, so I've cut my piece effectively 2 inches thick, 2 inches wide, and lo and behold, and you can just see that. Let me see, come on, focus. Snap, right, you can just see that crack going through there, which is on this face. So I know that I've got a machine quite a bit off this, and ultimately this will end up being in cross section. It'll have looking through from the end, it'll basically be so that angle there will be less than 55 degrees. That distance will be something like 1 3/4 inches, so say 50 degree angle, and all of this will be machined away. We're just chewing off the ends. We need 10 inches any longer than that and we can't cut it on the shaper, so doing the first cut and then we'll get the length and cut the second in. There was some serious stresses when I was cutting the length of it. I got down to 40 mil deep cut, and it sprung and grabbed the blade and seized the mill. So that was frustrating. That's the final pass. Let's cut the end off. Must be handy having a bandsaw that cuts steel. So we finished the cut. Slight problem with the clearances. Ended up having to drop the table part way through the cut. It was binding between here and the underside of the arbor support. It's stuff like that that I keep getting wrong because I don't do it often enough. Anyway, no harm caused. I'm just machining off the mill scale or chill or whatever you call it, the outside anyway. We've got a carbide bit in because it's a bit like knackers your cutting tip if you use high speed steel, I found. It's an 80 thou deep cut with 2 mil deep, and we're stepping over 1/3 of a mil. And we're running around about 50 strokes a minute. This is the final pass on the second side. So we've got a pair of sides at 90 degrees to each other. I think it can benefit from running at a slightly slower rate, but I've already got the motor only down at 40 hertz, not 50. This machine's it's called a high-speed shaper. It's geared for aluminium and steel rather than cast iron. So that's how we were planning on doing the angled face. So we get an included angle there of less than 50 degrees. Table tilted over to its maximum is 32.7 degrees, and it ain't enough, which is annoying. So I think I have to relocate the vise onto that side, and then obviously not as much tilt. Yeah, love it when things are straightforward and easy, and you know, arse. I think it's time for a cup of tea. Well, this is one of those sod jobs. that no matter what I do orientating the box, I'm 5 degrees, well 10 degrees out of what I need. There's near as damn it 30 degrees of tilt, and I need 40. So I'm going to rough off as much as I can in this with the auto feed, and then I'm going to tilt the box back the other way and take the head over to give me the angle I'm looking for. It just means that the last half an hour I'll be manually moving the handle on the head, as if I was taking a side cut. Tedious, but there we go. Well, this is a convoluted setup. So the box is tilted round to approximately 30 degrees, and the head is tilted 20 degrees, which should give us 50 degrees, which being less than 55 should mean I can get it into the slot. 55's the scribe line, and the lighter line is 50, which is where we're aiming for. So as long as I'm this side of that scribe line on an angle, I should be all right. Excuse me as I hiccup. I'm out of cutting tools that are the right kind of shape, so I'm on a carbide turning tool, virtually no top rake or back rake, so we're going to see how it goes and I'll tweak it accordingly. Bring you back when we're cutting. Well, that's the rough machining done. Well, that's all the machining done, so no more machining. Machining is over. It's taken me all day. There's a slight misalignment and some knife edge there, and a couple of mil there, but for our purposes that ain't a problem. So the next job is basically deburr it, drill a hole in each end, tap it, and then that face and that face have got to be scraped by hand, and also clean up the crap. I thought I'd better take the box off to clean the cast iron crap from these mating faces. As the 3 studs are bolt nuts on the end of them, and that's the rotation. I did consider taking it off and just opening these around a bit more, but because of that I was a bit nervous of that. Anyway, we got done what we needed to get done, so we can put it back together. It's had a good clean. That's set at 48 degrees, I think it is. Can you see that? As near as damn it 49.5 degrees. So it should fit. The moment of truth. So it goes in like that. Tip it up. That's fortunate, isn't it? Right. Get this edited and send it off to Emma. See what she thinks. See whether I can comply with the rules.